All right, guys, welcome to another episode of Cuda Education. Today, I wanted to correct something that I think I didn't do quite right the last time. So I will just rehash the whole kind of lesson, specifically dealing with the specialized compute queue flag. Okay, so right now I'm running this algorithm basically with the algorithm assuming that the graphics queue family and the compute queue family is the same. And the reason for that is my particular GPU, which is an NVIDIA GTX 1050 Ti, GeForce 1050 Ti. It's built with the graphics queue family and the compute queue family being the same queue, right? So there's no distinction between graphics work and compute work when it comes to the queue family. It's the same thing. So whether the algorithm is throwing compute work out or presentation work out, it's the same queue family. All right. I just simulated wind right there, so that's what you're seeing. Okay. But when I forced the algorithm to turn on specialized compute queue flag, which basically forces it forces the algorithm to separate out compute work from graphics work, and then having to use synchronization or not really synchronization, but switching logic to accommodate both. I don't believe I did it right the first time. So let's just go through this real quickly. I don't want this to be a long video. I just want to correct my mistake and keep it moving. Now, of course, the first thing, if you want to be able to run this algorithm on your machine, you need a Windows capable machine. I mean, a Windows based machine with a Vulkan capable GPU. That's what you need in order to. You need that, and then you need tutorial number 1 and tutorial number 13, which is in the description below. The links are in the description below. This algorithm is freely available on GitHub. I'll put a link for that below. The author was very nice and kind to make it freely available online for all to use and learn how to run Vulkan and program Vulkan and learn about all the intricacies of the Vulkan API. Anyway, so right now I have everything turned. The specialized compute queue is turned off. It's turned off because first it's initialized to false, but that doesn't really matter. What happens is that this logic basically it basically fails. So what it's doing is saying, is the graphics queue family, does the graphics queue family not equal the compute queue family? In this case, this because it's a not equal, it resolves to false because of this not equal logic. So as I said, on my GPU, the graphics and compute queue family are the same. So this resolves to false. Okay, so because it resolves to false, and then we have our flags here that basically, if specialized compute queue, we do special logic. If this runs true, this is where we enforce whatever this flag says, right? So we just ran it. We just ran it with it being false, right? Let me basically do it one more time. I'll do it one more time. All right. And you could see how it runs, right? So graphics and compute work is basically going to the same queue family, and it's running really fast, right? But now we're gonna have to change this thing. So we're going to initialize to true, which is fine. Okay. So specialized is initialized to true, but we're just starting the algorithm. This is just the beginning. This is just initialization, right? But the important thing which I needed to correct, I needed to comment out this because this is going to change back. Notice that this is in the prepare section of the code, but it's going to change this back to false. So I need to comment that out. Now, in my previous video, of course, we talked about the switching logic, which I'm not going to go through again right now. But what I am going to do is make sure that all calls to the switching logic is commented out. All right. So all calls to switching logic is being commented out. So remember, the title of this video and you know what this series of discussions is, switching queue families, right? So we're going to turn off all the logic as it relates to switching, and we're going to force it. We're going to force it to make a distinction between graphics work and compute work. Okay. So I already discussed these things in previous videos. So we're not going to go through that again, but just bear with me while I update the algorithm and we see exactly what happens. Wait, did I miss something? This guy. Right. Let me just run through it again, make sure that everything is everything. All right, so we're good. So we're gonna rebuild compute cloth, and once it's rebuilt right here, we're gonna run it, and we're gonna see if there is a difference. So while we're waiting for it to build, remember again, I'm forcing my basically the algorithm and the system. I'm forcing it to go through specialized logic for compute work, compute queue work, and graphics queue work. But not only am I forcing the logic to do that, the algorithm to do that, but I'm also turning off all kind of explicit switching logic. So all of these if statement things are I'm turning on this thing, but at the same time I'm making sure that, so I'm turning this on, right? So we do the specialized thing, right? So I'm turning on the specialized logic, but then all the queue family switching logic is being commented out, right? So I'm not explicitly, you know, I'm not explicitly managing the switching between the queue families. All right. Hope you guys can follow what I'm saying. Now, I don't know if all of these add functions are necessarily being affected by the specialized flag, but we're not going to worry about that for now. All right, so we built it now. Let's run it. Give me a second. All right. So notice, guys, that it still runs, but if you could see, for whatever reason, the whole thing is it runs a lot slower, at least from this. I can't vouch for the frame stuff, but on this side, you notice that the cloth falls a lot slower. You see, it's markedly slower. And then even when you turn on the wind, it just it's just slower, right? So we've basically proven that it's slower when we. So let me go back to what we initially had. Right. So let's rebuild. So we're going back to the initial setup, where we specialized compute queue is false, and then the test also makes it. The test also makes it, you know, or confirms that it's supposed to be false, right? And then we are going to run it. All right, let's go. So you notice that it runs a whole lot faster as far as the animation itself and the rendering, right? And even when we turn on the wind, you know, it just runs faster. It's smoother. It's more seamless, right? Let's do it again. All right, one more time. So you know, it's when you're explicitly managing the I mean, when you're it takes advantage of the fact that the compute work and the graphics work is all part of the same queue family. It works fine. We could also, there's a third thing that we could do. So what I previously did was forced it to do specialized queue, but I turned off all of the switching logic, right? So switching between the queue families. But what I could also do is make it true, make the specialized logic true, right? Um, so I'll just comment this out. So we're gonna do the specialized logic, right, for compute and graphics. So we're gonna make it true, but then we're also, I'm not going to disable the switching logic, right? So we're basically acting as if my GPU has different queue families for graphics and compute, but we are explicitly making sure that we manage the relationships between the two queues, and we're switching properly and all that stuff. All right, so let us see how that runs and compare it to what we just saw. did I save? I'll just do it again. Sorry, I didn't know if I saved it. I don't know if it automatically saves or whatever, but let's just do it again. So again, we are doing the specialized logic, but we are actively managing. I didn't disable any of the add stuff, right? So none of the add stuff is commented out. All right. Yeah. Okay. All right. So that's good now. So let's all right. So, I don't really see a marked change between forcing it to do the specialized logic, assuming we manage the switching. I don't necessarily see a big difference between this and when we just assume they're both the same Q family. Okay, so it's there's not much of a difference. I maybe it's a little bit slower, I would say, but I can't really say it's a difference. I don't really have faith in this frames per second thing because it's not consistent with what we're seeing with our own eyes. Okay, so there you have it, guys. That is our lesson for today. So we did three things. I'll just review real quickly one more time. So we did three things. We ran it without the specialized logic, right? We ran it assuming that basically, and my system my system has the Q family and the graphics Q family and the compute Q family is the same. We ran it that way. And it ran fine. Then we forced specialized compute Q flag. We forced it to do the specialized logic, but then we commented out all of the switching functions that manages the switching between the compute work and the graphics work. And we ran that, and it was a lot slower. And then the last test that we did is that we forced the specialized compute queue. So we forced it, we turned it on, and we also did have the switching logic turned on. And we noticed that the first experiment and the third experiment were pretty much same performance. So the first experiment where we're assuming compute and graphics are the same, and on my GPU, that's fine. And we run it. That animation was fast. And the third situation where we forced specialized compute queue, but we also made sure that the switching logic was turned on, that ran fast and was consistent with the first experiment. The second experiment where we force the specialized compute queue, but then we turn off the switching logic, is when we noticed with our eyes that the rendering or the animation was a lot slower. So there you have it, guys. That's the lesson for today. Remember, if you guys want to run this algorithm yourself on your machine, you need tutorial number 1 and tutorial number 13. This code is freely available on GitHub. You could get it for yourself, but you need tutorial number 1 to install the Vulkan API on your machine, and you need tutorial number 13 to install all of these examples that you have here. These are all Vulkan examples. You'll be able to run it, assuming you have a Vulkan capable. However, if you want to do the ray tracing examples, you need an RTX or better NVIDIA graphics card. You need a ray tracing capable graphics card. My machine is NVIDIA. I have a GeForce 1050 Ti. Unfortunately, they don't enable ray tracing logic on the GeForces. You have to get the RTX series cards or later in order to run the ray tracing stuff. So, that's a battle I will fight at a different date. But I need to understand how everything else works. I do have videos on this example stuff, like running them and seeing what it produces and stuff. So you guys can check that out. All right, guys, thank you for watching. Please support the channel, subscribe, tell your friends, learn the Vulkan API. It is the future. OpenGL is done, and I don't really have an opinion on DirectX, but Vulkan API, guys, gotta stay with the times. Have a good day. Bye bye.